What's going on, dudes? Today is the first day of class, and so hopefully I'm going to get everything up and running. I'm going to ask that everybody turn off their microphones. Let's see. Because, I'll tell you why. If you don't turn off your microphone or don't mute yourself, then what's going to happen is you're going to have it's gonna like get all buggy and echoey and all that kind of stuff. Now I just closed my desktop sharing, so I need to find that again. Let's see. Let's put this here. The desktop sharing over there. All right, and this will work like this. I think we're good. All right. All right. How's the audio coming through? Can you hear my voice? Yes, good. How's the video coming through? Can you see my ugly face? Or my beautiful face?
No.
No, you cannot.
No.
Let's see. Well, first of all, somebody's answering no, which is not a good thing because I just told you to turn off your microphone. Second of all, the webcam should be up. Maybe look for a little tab on the bottom that says webcams. I clicked a button. Did that force you guys all to have this, like, all of a sudden going so you could see my face at the top right-hand corner? Oh, I get it. Okay. That probably hid, but when you chatted, as soon as you chatted, that hid that little window right behind there, huh? Okay. All right. So you guys chatted, and then the chat window went right above it. All right, there. I moved myself to the bottom left-hand corner. Did that work? Awesome. All right. I'm going to do my best to make sure that the voice is not glitchy. To be honest with you, sometimes this technology doesn't really work. Now the desktop's in the way. Oh, great. All right, let's see. Let's do this. Okay, moving it so that everything is all nicely put in there. There we go. How's that? Nothing's in the way of nothing. You still can't see me. All right, Seamus, come on. Does it work now? All right, cool. All right. I'll be honest with you, Seamus. I know I'm a really good-looking guy, but you don't really need to see me. That's not like that's not like required. I just put my face up there to kind of add that personalized experience. But to be honest with you, it's not like oh, I don't see Mr. Dollday. I can't hold class now. I'm done. You know what I mean? All right. Okay, so welcome to class. I basically gave you the rundown of how class is going to work. I need to start covering some material with you folks, and so why don't we get started with this without any further delay, if that's all right with you? Cool. All right. We need to talk about waves. What do you know about waves? Here's a wave. It's a wave that's breaking over the ship. This ship is a NOAA ship. Today we'll learn about the physical force that causes waves to form and break. A wave is a wave, yes. And I'm sure that people who are... Can I please wave? Oh, Isaiah, why don't you hold off on chatting with your other neighbors right now. A wave is a wave to surf. I like that. Yes, that is a physical wave, and people surf on those things. Now, here's the thing about a wave, which I think is really interesting. Does a particle of the wave move right to left? Does that make sense to you? Does something on the wave move right to left? You guys say no. But wait, a lot of you are saying no, but wait a second. Surfers move right to left, right? They move horizontally. So why don't things in the wave move right to left? Do you see what I'm getting at here? Have you guys ever been to a football game at the Aloha Stadium? Or maybe not a football game at the Aloha Stadium, but you guys ever been to any kind of sporting event where they did the wave? Okay. For those of you who said no, do you understand the concept of the wave if you went down to a sporting event? Yeah, I'm not talking about paddling here. I'm talking specifically about the wave. You know, like, hey, you guys, we're going to do the wave, okay? And then everyone goes, woo! Right? And the next person goes, woo! That kind of stuff, right? Wave with their hands. Right, exactly. They go up and down like this. Right. Do you guys understand that concept? Okay, so Michael Tejada, who is late, we are talking about waves, and we're talking specifically about a specific kind of wave. It's a very weird wave for Mr. Dalton to bring up, but it's the wave called the wave when you go down to a football game or a basketball game or a volleyball game or whatever it is kind of game you like going to. They often do this thing called the wave. And even if you've never been in the wave, do you understand the concept of it? I could show you a YouTube video about it, but I mean, you understand what I'm talking about here, right? The woo! All right. For those of you who need its explanation, if I were to do a wave and I were standing in a circle, I would go woo, and then the next person would go woo, and then that person next to them would go woo, and then it would look like there's a wave kind of going around the circle. And if you get a stadium of 1,000, 2,000, 3,000, 10,000, 20,000, 100,000 people doing that, it looks pretty awesome. Cool? So maybe if you've never been in it, at least you've heard of it. Or at least you can imagine Mr. Dalton describing it. Now here's my question to you. That wave moves around the stadium. Right? It's going in a circle around the stadium. Agreed? Okay, good. And you know what my favorite thing is to watch this chat part, the chat bar over here on the side over here. I love watching this chat bar, you know, fill up with your responses because I'm going to ask you lots of questions. And I want I want everyone to give me those quick responses. Yes, no, yes, I agree, cool, all of those kinds of things. I'll even ask you specific words to tell me, like, is everyone cool with that? And you guys should all say, cool. And everyone types it in. That way I know everyone's engaged. We're engaging everyone here. I don't want the same people answering. Everyone needs to throw their answers up on the board. Because I have a record of this, and then I basically take a look at who responded and who sat in the back of the class. All right. So that wave moves around the stadium. Got it? In fact, you know what? It is kind of important that you see my face right now, because I'm just having a discussion with you folks. But here's the thing that I think is really interesting. Do the people move around the stadium? No. The people just move up and down. They just stand up and they sit down. And then they wait for the wave to come all the way around. And they stand up, they sit down. And they make a lot of noise. They go, woo! But they don't move side to side, even though the wave itself moves side to side. Did you guys ever realize that? I think that's interesting. Yeah, you always knew that, but essentially, when I ask you, does particles of a wave move horizontally, the answer probably is, a lot of people say yes, but the answer is no. All a wave is it's a disturbance in a medium. It has to have a medium, and that's important to understand as well. When I say the word medium, I basically just mean stuff. For example, a sound wave, the medium is air. A water wave, the medium is water. It's the stuff the wave moves through. A sports center wave, the wave that we've been talking about, the medium is people. You can't have a wave that doesn't travel through a medium. It doesn't make any sense. Does that make sense to you? For example, okay, Star Wars, watching Star Wars. Technically, we're supposed to watch Star Wars. It goes like this. Right? If I were to get my little airplanes here, I would have this. I would have this situation where I've got a little jet here and a jet, and they go, that kind of stuff. Cool? All right. What Star Wars really should sound like is this. Why? By the way, your microphone wasn't broken. I just didn't say anything. It just looked like I just looked like an idiot pretending to say stuff, but I didn't say anything. It was just see, still not saying anything. Why? Why would there not be any sound? Ah, there we go. Because there's no air. I like it, Titus. Awesome. And if there's no air, then there's no what? There's no medium, hence no sound. Because sound needs air to travel through. All right, so we talked about these things. This is how I run class. I just start talking about things and saying, that's interesting to me. Let's take a look at that. Anyway, let's keep going, all right? I know I covered up my face. 1 second. Let me just make this video a little bit smaller. There we go. I've got a small little face now, and I'm going to show you this thing. And then I'm going to click on the next slide. All right. A wave. A wave is a transmission through energy, or of energy through matter. Now, that doesn't mean the things in that wave gets transmitted through the wave. It just means the energy in that wave gets transmitted through the wave. Notice that definition number 1, and I need to be very specific about this. You can't see anything. That's not a good thing. Can you see anything now? Okay, I know Julian really wants to be called JP or Marcus. I understand that. All right. You can't see. I can't see. I can't see. This is not good. Let's see. What is it that you can't see? You can't see. Oh, you can't see me. Oh, I made my camera really small. Can you see the slide? The slide is what's important right now. No, no, yes, no. Okay. Can't see the slide. On your big blue button window is a bunch of small windows, and that window will show you the slide, or it's a window called desktop sharing. Try finding that one. If not, what you have to do is log out and log back in. Find the window that says desktop sharing. That way you can see the slide that I'm working on. Or log out and log back in, and hopefully that will work for you, because I know that this thing is displaying correctly. The slide, it's actually a screen sharing of my other computer. All right, good. All right, if you guys can see it, then I'm just going to keep moving on. All right. There are two important types of water waves, and this is the ones we're talking about. One is deep water waves, and the other one is shallow water waves. And we talked about what a tsunami is. A tsunami is also called a tidal wave. If you're American, if you're Japanese, it's called a tsunami. I don't know what people in Hawaii always call it. I was always told it's a tidal wave, but then I was also always told it's a tsunami. It's the same thing. Yeah. Tsunami, I think, is just the Japanese word for it. All right, here we go. When energy moves through matter, like water, and they use the word matter, but I'm using the word medium. Okay, so that's the same thing. The word matter and medium, those are the same word. When energy moves through matter, like water, matter moves and returns to its initial position. Okay, so the matter moves, the stuff in the matter, it moves around, but it comes back to its original spot. And I think that's an important concept to understand. That's kind of like the people in the sports wave standing up, they're moving around, and then they sit back down. They're moving back to their original spot. The energy is transmitted to its adjacent surroundings, in this case to adjacent water particles. Transmission of energy through matter or through water moves the water particles in a circular motion known as orbital motion. So actually, when I ask you, does the water move right and left? It kind of does, but not really. It moves a little bit right and left. It kind of just moves in a circle, a small little circle. So the sand particles will move kind of in a circle like this. So yes, I guess it moves a little bit right and left, but I mean, essentially, it comes back to its original spot. And I think that that's an important concept for me to try to teach you. Does that make sense? So the wave itself, or at least the stuff that makes up the wave, doesn't actually move forward like a surfer, okay? The wave just kind of, here's the wave. The things in the wave just kind of move in a circle like that. You guys got it? Michael, I know you're okay, but I mean, don't spam the class. But that's different from a surfer who's riding the energy of the wave. They move horizontally. They don't move in a big circle. We cool? They move forward, right? Which makes a lot of sense. All right. Just want to make sure you guys know these things. Oh, oops, I went one too far. Okay. So, let's talk about parts of a wave. Yeah. I'm not necessarily the best artist, especially on a computer. With a mouse? Are you kidding me? All right. Let's talk about parts of a wave. And I want to talk about this. This is really important, okay? Anyone here, is anyone here a surfer? Me, okay. You guys all are. All right. Seamus, what you're going to have to do is you'll probably have to log out and log back in. All right. Now, for the surfers, maybe you folks aren't old enough to know this. Maybe some of you are. I don't know. I'm not a surfer, so I don't know these things. But if they say North Shore is, like Waimea is 6 feet, what does that mean? The waves are 6 feet at Waimea. What does that mean? This is for those of you who are surfers. Wave in the back is 6 feet. Okay, wait. All right, wait. Let's focus in on what Riley and Bo are saying. Okay, Riley, you're saying wave in the back is 6 feet, and Bo, you're saying from the top to the bottom is 6 feet, and Eden is saying the face is 6 feet. What are you talking about here? That's what I really want to understand. What are you talking about? The wave is 6 feet up from. So Isabel, all right. So we've got Riley saying from the back of the wave. So the back of the wave is maybe over here. To the top over here is 6 feet tall. Right? We also have Isabel saying the same thing because she's saying the rest position. The water is normally at this height over here. Got it? Whereas we've got Eden and Bo, and I think it was Eden, Bo, and maybe Riley was saying this is 6 feet tall. You guys understand? So let's take a vote. Is it 1 or 2? What do you folks say? I got a bunch of 1s. 2s, okay. All right. Hang out on just the chat, on chatting for just a second. Don't chat anymore because I want to start talking to you guys, and so I want you to listen. Actually, it depends. It really depends. And this is the most confusing thing I've found, to be honest with you. Back in the day, old school surfers, they used to measure the waves from the back of the wave to the top. So that means, I think it was, I'm not sure who originally said that. I think maybe Bo and somebody else said, you know, or Isabel and Bo would say, this is the way they used to measure things. And I think surfers used to call that Hawaiian style. Have you ever heard that? Like Hawaiian style is measured from the back of the wave to the top. And that just means you're measuring from you know, the middle point of where the water normally is to the top of the wave. That doesn't mean that you are surfing a wave that's 6 feet tall. That actually means that you're surfing a wave that is 12 feet tall. Right? Because if from the middle to the top is 6 feet, then the middle to the bottom is 6 feet as well. So that means you're going to be up against a wave that is 12 feet tall. Okay. So what happened is the surf report would come out and say, oh, pipeline's running 6 feet, Hawaiian style, right? And people would be like, oh, or they'll say stuff like, oh, pipeline's only running 3 feet tall today. Does that make sense? And people from the mainland, right? We'll call them the haoles, which I'm not referring to anybody. You know, haoles just means people who don't know about the local words. People from the mainland, they would say, oh, I can go out and surf a 3-foot wave. Well, that's easy, right? That's easy. I can go out and do a 3-foot wave. Shoots, bro. Or they would probably say, well, very good. I'm very excited to surf a 3-foot wave, right? And they get out there and they realize, wait a second, a 3-foot wave is not and they'll realize this very, very late in the game because they'll be surfing out there and they'll be like, well, it's only 3 feet today. And then they'll realize that there's a 6-foot wall of wave coming at them, and that measuring 3 feet was actually measuring from the middle to the top. So they would crash and die. No, I'm not being racist. I'm just saying, like, people who don't know about the Hawaiian style would say, hey, there's a 6-foot wave, and they would go out and they say, well, I'm 7 feet tall because, you know, people from the mainland are really tall or something like that. And they say, oh, I'll go out and go surf this wave, and then really it's a 12-foot wall of water coming at you, and then they'll crash and die. Make sense? Now here's the problem: is that we've actually had this. This is true story. I'm telling you true stories, and the reason why I'm making it such an absurd story, which is actually not a false story, it's a true story. The reason why I'm telling you this to you is because I don't want you to forget these concepts. I really want you to memorize these things. So for me, instead of just having you memorize a bunch of facts and a bunch of things, I'm telling you stories to remember, ways to remember them. So they would go out and they would try to surf these 6-foot waves, which were actually 12-foot walls of water, and they would crash on the rocks and they would die, and that would be a big problem for Hawaii tourism. So what they say nowadays is they say, oh, we should change it. When we say it's a 6-foot wave, we should measure it this way. Not Hawaiian style. Does that make sense? Because then if we say a 6-foot wave, it's actually a 6-foot wall of water. We won't be saying a 3-foot wave and then people are going to go out there and get killed and hurt themselves. So if you're an old school surfer, you would measure a wave from the back to the top, or from the middle to the top, or as Isabel said, from the resting position to the top. And that would be Hawaiian style. If someone said, oh, it's 6 feet Hawaiian style, that means they're talking about from the middle to the top. Are we cool? But if you're more recent of a surfer, they've changed the way they report waves, and they would tell you, I don't want to call it haole style, but let's call it, I don't know, new style. They would measure the whole face of the wave, as I think it was, I forgot who said it, I think it was Bo who said it. They would measure the whole face of the wave. Are we cool? Does that make sense? Yeah, we can call it mainland style if you want, whatever. All right, now, here's my question to you. In science, which one do we use? Do we use Hawaiian style or mainland style? Well, I hate to say it, my friends, but in this case, the Hawaiians got it right. In science, we use Hawaiian style. Every single time I've seen waves, it's always been measuring from the middle to the top. That is called the amplitude of the wave. And so if I tell you to measure the amplitude of the wave, I want you to measure from the middle to the top, or the middle to the bottom. It's the same number. But here's the thing that's interesting to me, is when we talk about water waves specifically, and this has been weird to me. I don't understand why this is exactly, but when we talk about water waves specifically, when you're talking about the wave height, you're talking about the whole wave. It's the new style, the mainland style. You measure from the top of the crest to the bottom of the trough. Are we cool with that? Does that make sense? So I'm not trying to tell you this. What I've done in the past is I told everyone, I said anyone who uses mainland style is ridiculous, because that's the wrong way of doing things. And in science, I've never really seen anyone use mainland style. I've always seen people use Hawaiian style from the middle to the top. But when it comes to water waves, it seems to me that people measure waves from the bottom to the top, which is a little weird to me. And I'm just kind of telling that to you so that you understand that there's a difference here. Now, Michael, I appreciate that you like cheeseburgers, but let's be serious here. Because I'll tell you what, I can always take this chat and copy and paste it and send it to your parents and say, this is what your child has been talking about in class. And Mr. Dalday is fun, but Mr. Dalday also wants to make sure that you have a good education. So I'm going to balance those kinds of things. Cool? All right. Let's talk about other parts of the wave. So we talked about the height of the wave, and we talked about how the height of the wave is different depending on what you're measuring. Most of the time, it's measured from the middle to the top when you're talking about sound waves, when you're talking about sound waves, you're talking about light waves, when you're talking about all of the different kinds of waves. Except when you're talking about water waves, it seems to me that people measure it from the bottom to the top, and that's a little weird for me. All right, let's go back to our wave. The bottom right here, this is called the trough. That's the bottom of a wave. And the top right here, this is called the crest. We cool with that? Now the crest, if you measure the crest to the top, that is called the face of the wave, which, you know, we talked about that. The wavelength is measured by measuring the distance between the one crest and another crest. Do you understand that? Now that's not actually true. I mean, what you could have is your wavelength could be measuring one trough to another trough. And that's the same distance, really. So I guess maybe the best way to say it is the wavelength is measuring from one spot to an exactly identical spot on the other side. Some people like saying that crest to crest, or some people like saying that as trough to trough, but we call that the wavelength. And I'm going to call it L. Does that make sense? All right, cool. Let's see, if there's a slide back there. All right, here we go. Okay, the period of a wave. The period of a wave, they have these things right in front that are kind of annoying. Let's see. The period of a wave is something different. I need to talk to you guys about that. The period of a wave is related to the wavelength. I suppose that the best way to measure the period or to talk to you about the period is it's how often a wave comes into, strikes the shore or something like that. It's how much time it takes between one wave hitting and another wave hitting. Are we cool with that? All right. Okay, I'll try to speak slower. If my mic has been messing up, I apologize. I don't know how to fix it because they didn't give us any way to fix this. So we're using new computers, a new system. Hopefully this will all work out. Let's see. A deep water wave is when a deep water wave occurs when the depth that the wave is between the wave and the ocean, or the ocean floor and the wave, is smaller or is bigger than 1/2 of the length of the wave. So how do I classify deep water waves? Well, I'll say, okay, I'll measure the length of the wave. For example, like let's say the wavelength is 50 meters. Wavelength. We'll call that L. All right? A wavelength is 50 meters. And let's say the depth is 20 meters. Is this a deep water wave? No, it's not a deep water wave. Because half of the length is 25, this would be 1/2 L. And that's not, and your depth is not bigger than half of the length. So this is not a deep water wave. Does that make sense? All right. A shallow water wave, on the other hand, a shallow water wave is when the depth is smaller than 1/20th of the waves, of the length. So if my wavelength was, let's say my length of the wave was 60 meters, and 1/20th of that is 30 meters. And my depth is, let's say my depth is 15 meters. Is this a shallow water wave? Actually, I'm sorry, not 20. I'm sorry. 60 divided by 20 is not 30, it's 3. Is this a shallow water wave? No, because your depth is way bigger than 3. But let's say your depth is 2 meters. Is this a shallow water wave? Yes, it is, because your depth is smaller than 1/20th of the length. All right, cool. I think this is interesting. Shallow and deep water waves can occur at the same time. How would that occur? To be honest with you, I have no idea why they have that statement. I can't think of an answer. If your depth is smaller than 1/20th but bigger than half of the length, that doesn't make any sense to me. I'll have to get back to you on that statement. All right. A typical tsunami wave is several hundred miles long. An example is, let's say, a wavelength is 400 miles. Man, that's a big wave, or a long wave at least. The deepest part of the ocean is 7 miles deep. Based on this information, do you think a tsunami is a shallow or deep water wave? Yes, I agree with you. It's 11:09. We don't have time. How much slides do I got? Oh, okay. Well, I'm not that far from finishing. Do you guys mind if hanging out just a little bit? All right. Well, if the length is 400 miles, then the 1/20th of the length is, let's see, 400 divided by 20, that would be 20. And the depth is 7 miles. So tsunamis are all shallow water waves. And it's interesting because tsunamis are shallow water waves that are shallow water waves even in the deepest part of the ocean. I think that's crazy. The ocean would have to be deeper than 200 miles on average for a tsunami to be a deep water wave. A tsunami is a shallow water wave triggered by a displacement of a large amount of water. And when we say displacement, we discovered that the best way to displace the water would be the earthquake. We talked about this in the science experiment. All right. As waves go into the ocean, the water level, the depth decreases. Does that make sense? And what happens when the ratio, if you divide the height as to how high the wave increases divided by the length is 1/7 or is bigger than 1/7, what happens is that is when a ratio, when the wave will break. So that's when you're going to have the wave not change from looking like this to looking like this. And this is the one you want to surf. Unless, of course, it's a tsunami. And then you're in trouble. I'm not sure what teen biz is, or 10 biz. I don't know. So when your height of your wave divided by the length of the wave is bigger than 1/7, then your wave will break. This is a thing we're defining. And I bet you didn't know this when you're even in surfing. So I think this is interesting stuff for me to cover with you. All right. Waves can be very destructive. A tsunami is one type of destructive shallow water wave. Can you outrun a tsunami? All right. I think that I've covered my topic on waves with you folks. I hope that was helpful. Do you folks need help with ArcGIS? It looks like a lot of you folks have figured that out. So I'll tell you what I'll do. For some people who didn't like ArcGIS, I moved the due date for that back from Monday to Wednesday. So now it's going to be due on Wednesday and not Monday. Hopefully that will give you some more time to figure this out if you need help. I'll also cover a little bit on Wednesday with you if we have the time. All right, but class is over and I have to finish, so I'll talk to you folks later. All right. Bye-bye. Let's see. This, stop recording.